Hi everybody, Mrs. Davis here. I'm back with a video to help you out on the worksheet you were assigned. This one on the bottom it says D52 and on the top of it it says why do elephants have ivory tusks? So I'm going to help you out on this sheet. This is with the regular or composite figures. So if we look at the first one's a rectangle, so I just skipped over it for you. So I'm looking at the second problem, number 2. So it looks like this. So I gave you kind of a clue in the trapezoid video at the end that one strategy that you can use to go about doing these types of shapes when you have to find the area is to break it into shapes that you already know how to find the area of. So I love to do these in class usually because I love to see the way that students' minds work so differently. Like one student might see it one way, another student sees different shapes, but can't do that. So I'm going to go through just a couple examples of how you might see it at home right now, okay? Alright, so one way, and often students see this shape broken up like this. So they kind of have broken it up into two shapes. Now, when we break it up into two shapes, we need to be very careful and look for the measurements that we need for the area. So let's start with this small rectangle here. So with this small shape, I have this 2 meters already labeled for me. But I have to figure out what this is. So if I look kind of over here on this side, if I look from here to here on the shape, from here to here is 2 meters. Well, if I go over here and say from here to here is 2 meters, then that leaves me this from here to here, which if I look, the whole thing was 4. So 4 minus this 2 meters means that this top part is 2 meters as well. So this is 2 meters. So we actually have a square there. So the area of this square, 2 meters times 2 meters would give us 4 meters, okay? Now we look at this bigger shape here. So we know this part is 4. But what we don't know is all the way across what this is here. Now we know the whole giant shape is 6 meters across. We know that this part from here to here was 2. So if I take the 6 meters that the whole thing is and subtract that 2, I know from here to here it's 4 meters as well. So we have another square. So we got 4 meters times 4 meters gives us 16 meters. Now we're not done. We got this shape and this shape, but we have to put them together because we want the area of this whole irregular figure. So 16 meters plus 16 meters gives us the area of 20 meters. And guys, I forgot my square on all of these. Squared, remember, because we did meters times meters. So 20 meters squared is my answer. All right, now you may not have saw it that way when you looked at it. You may have seen, Mrs. Davis, I didn't see it being cut up like this. So maybe when you saw it as being cut up like this. So let's check it. If you look at it this way, we have two rectangles. So if we look at this bottom one first, we have this 2 meters. Then we have this long length here again. So if you remember from the last one, we knew if this was 2 meters here, then this top part from here to here is 2 meters, which made this part that we labeled 4 meters. Remember, we labeled this part 4 meters on our last one, which means the bottom is also 4 meters. So down here, this is 4 meters. So our area for this rectangle is 2 times 4, which was 8, and we have meters squared. I remembered that time. Okay, now what about our top? Our top rectangle there. Well, we got our 6 going all the way across. And now I got to figure out what this part is. But if you remember, when we just did the last one, we said if this was 2 meters, then this was 2 meters because the whole thing was 4 here because we did 4 minus 2. So We know this is 2, so we know this side is 2. So 4 minus 2 means that this part must also be 2 meters. So for our area up here, we got 6 meters times 2 meters, which is 12 meters squared. Now again, we got to add them up. So 12 meters plus 8 meters, once again, gives us 20 meters squared. And that's what we got on the last one too. So that's good. So that's kind of like piecing them apart. Now there's another way, and sometimes students find it easier. Sometimes students don't like this way at all. So it's up to you where you fall in this. Maybe you're going to love this way, and maybe you're going to be like, I don't know what you're talking about, Mrs. Davis. Let me just go back to the way we were doing it, which is fine. Everybody has their own way, right? So this way, you actually use subtraction. You don't add the areas together, you subtract. So can you think of any idea of what I might try here? Any idea? Yep. So what I'm going to do is I'm going to kind of fill in this whole thing and pretend we have a whole big giant rectangle here. So kind of visualize that. I got a rectangle. The length is 6. Its width is 4. And I'm looking at this whole thing. So if I had a whole big giant rectangle, the area of it would be 6 times 4, which would be 24 meters squared. So that's the big thing. But we don't want the big thing. We don't want this part here. We don't want to include this little square. So if you think about it, if I don't want to include it, I have to figure that out, then subtract it. So it's a square, so we have 2 meters by 2 meters, so the area of that square is 4 meters squared. So if I take 24 meters squared and subtract that 4 meters squared, I get the answer once again that we got for the other ones, which is 20 meters squared. So again, doesn't matter what way you go about it, you should still get the answer of 20 meters squared. And if I look on my paper, if I look down here, it's letter L down there. So L is 20 meters squared, so number 2 would have an L in it at the bottom. Okay? All right, let's check out one other problem from that paper, and it's just the next problem that we'll look at. So problem number 3 is the next one we'll take a look at. So problem number 3 looks like this. So kind of just stop, take a minute, think about how you're going to go about it. How do you think you would do it? We can start with the way that I just showed you, since it's fresh in our head right now. And the way I just showed you is to imagine this is a whole big giant rectangle. So I'm going to kind of dash this line in here. So I'm looking at this whole big giant rectangle, which once again has 6 meters by 4 meters. So that would be 24 meters squared. Now, if I don't want this part, I have to figure out what that is though and subtract it. So this is a rectangle, which is 3 times 2 meters. So this area is 6 meters squared. But I don't want this part, right? This is the part I don't want. So I'm going to subtract 6 meters squared. And when I do that, I get an answer of 18 meters squared. Again, we found a big rectangle and subtracted that little rectangle that we didn't want to give us 18 meters squared. Okay? So again, that's one way. The other way to look about it is to break this into shapes that you know. So let's take a look at how you may have broken it up into shapes. So maybe you took a look at this and you saw some different size rectangles here. So if you looked at it like this, you might look and say, okay, let's look at this big giant rectangle, and this one's going to be the same. It's going to be identical over there. So I know that this is 4, so I know it's going to be 4 times whatever this is. I don't know what this is, though. I don't know what this is. But if I think about it, I know this whole thing was 6. And I know this much of it is the same as this, so it's got to be 3. Which leaves me 3 for this part and this part. Well, if I cut 3 in half, think of $3. If I have $3 and I have to split it between 2 people, each person's going to get $1.50. So this is going to be 1.5. This is going to be 1.5. And then again, this would be 3. So we're going to have 4 times 1.5, which gives us 6. So 6 meters squared, which means this one is also 6 meters squared. And then we have this smaller one here. Well, we know this is 3, but we got to figure this out. Well, I know this whole thing is 4. And I know from here to here is 2, because this is. So from here to here, 4 minus 2 is 2. So I'm looking at this also being 2. So 3 times 2 is 6 meters squared as well. So 6 plus 6 plus 6 gives us a whole area of 18 meters squared. I'm pretty sure that's what we got on our last one too, right? Let's hope so. Yep, 18 meters squared. All right, one last way that you might look at it is like this. And if you looked at it like this, let me get my marker. If you looked at it like this, you might have saw these 2 small rectangles down here and a big one up top here. So let's start with the big one up top. Up top we got 6 as our length. And here, if you remember, we just did this. From here to here was 2, which meant 4 minus 2 left us 2 for this as well. So 6 times 2 meters gives us 12 meters squared. Okay, now down here, these are going to be identical. So we have our 2, and if you remember up here, we did this from here to here was 3 meters. So we know it left 3 here, and that's when I did the 3 divided by 2, or $3 split between 2 people was $1.50. So this was 1.5, which means these down here are 1.5 as well. So for this, we're doing 1.5 times 2, which is 3 meters squared. And over here, same thing, 3 meters squared. So we have 3 plus 12 plus 3, which once again gives us our 18 meters squared. So again, lots of different ways to do these, and you may have seen even different shapes than I did right now. Like some people might look at this and cut them up as trapezoids. So you have a trapezoid, a right trapezoid here, and isosceles trapezoid in the middle. It's all up to how you want to do it, okay? I hope this helped you. And if you have any questions, always feel free to email me. I also want to make you guys aware of something. I'm not sure. We only have a few students who've joined our Google Classroom for Team Tiffin. I sent out an email today directly to you and to your parents with the invite code, well, the class code, and kind of a picture of what it looks like. So if you're not sure what to do, you just get on Google Classrooms, go to classrooms.google.com, and you just log into your Gmail, your school email, and then you just click the plus sign in the top right corner, and then our class code I sent to you as well. So join in there. It's got some great information. It's another place where I've posted these videos, as well as Mr. Steinmetz got his landmark challenge on there. Mrs. Roth has been posting links to the book you guys are reading, so some helpful information there as well. So just want to invite you guys to all join in there, kind of a way for us to all keep in touch. Also, just to kind of get you there and get you motivated to get there, if you check out my shirt, I got a Pi Day 5K shirt, which I actually have an extra one here, as well as a Pi Day 5K medal. Ooh, check it out, it even spins. But I'm going to be posting some information on how you could actually win the shirt or the medal. So go check out the Google Classroom and get some great information there. All right, I hope you guys stay healthy, stay sane, and know that I miss you. Take care. Bye.